Good morning, everyone. Today, we'll continue with the last session, that is Unit 1, Part 2, that is problem solving. So, in this problem solving, we are going to discuss about how we are going to formulate a problem, what are the different types of problems, and states and operators, and state space. So, what do you mean by this problem solving agent? A problem solving agent is nothing but a goal based agent, and it is going to use the atomic representations. That is where we don't know the states of the world, and without no internal structure, we are going to visible to the problem solving algorithms. And what is the goal of these intelligent agents is they are supposed to maximize their performance measure. And what do you mean by this problem formulation? Problem formulation is nothing but it is the process of deciding what actions and states to consider given a goal. And the process of looking for a sequence of actions that reaches the goal is called as the search. And this search algorithm takes a problem as input and returns a solution in the form of an action sequence. So once we find a solution, the carrying actions it recommends is called as the execution phase. So this is what the problem solving agent. And one of the important applications of AI is problem solving. And these problem solving agents are also called as the goal directed agents. And a problem solving agent has three phases, that is problem formulation, searching solution, and executing actions in the possible solution. And a problem is can be defined by mainly five components, that is initial state, actions, transition model, goal test, and the path cost. So what is the initial state? It is the starting state or initial step of the agent towards its goal. And actions, it is the description of the possible actions available to the agent, so that what action if he takes, he will reach to the goal state. And what do you mean by this transition model? A description of what each action does. So when we take an action, obviously it will move one state to other state. So that is the resultant of the transition model. It simply describes what each action does. And goal test, it determines whether the given state is a goal state or not. And path cost, it assigns a numeric cost to each path that follows the goal. And it is this problem solving agent selects a cost function which reflects its performance measure. And finally, remember the solution what we are going to get is the optimal solution. What do you mean by this optimal solution is it is going to have the lowest path cost among all the given solutions. And here you can see what do you mean by this an optimal solution. It is a feasible solution where an objective function reaches its maximum or minimum value. That may be, we can simply say that the most profit or the least cost. And one more important concept in AI, that is state space search. So to find the solution to any problem, the first thing is it has to be precisely defined or represented. That can be represented by with the help of a state space search. So what do you mean by, let us define these three words independently. So in that, the very first thing is state. Any problem can be represented by set of possible states, and that state can be initial or goal state and various other possible states between them which are formed by applying some certain set of rules. And space, in any AI problem, the exhaustive set of all possible states is called space. Okay, the exhaustive set of all possible states, that we call it as the space. And coming to the one more important thing, search. In simple words, we can say that search is a technique which takes the initial state to the goal state by applying set of valid rules while moving through space of all possible states. Try to understand. It is a technique. Search is a technique where we are going to use some of the algorithms, search algorithms. Okay, that's why we are saying that it is a technique which takes the initial state to the goal state by applying some set of valid rules while moving through space of all these possible states. So these are interrelated terms, state, space, search. So to do a search process, we need initial state, set of valid rules, and the goal state. Remember, for any search process, we require these three things. And you look at this diagram. This diagram is nothing but a state space representation of tic-tac-toe. Here, I think everyone is familiar with this tic-tac-toe. So this is the state representation. So this is the initial state, and we will have a goal state. Starting from the initial state, what we are going to apply some rules of putting 0 or cross, and we are keep on generating the states. So this set of states, all such generated states, all these generated states, and here we'll move to some state. So these are all nothing but this is called as the space. Okay? Unless we reach one of the goal state, or that may be a winning situation or a drawing situation. So these all are nothing but the space. Okay? So this is how a particular problem can be represented with the help of a state space representation. Then coming to the problems, basically there are two types of problems and AI can deal. One is the toy problem, another one is the real world problem. So toy problem, it is a concise and exact description of the problem which is used by the researchers to compare the performance of algorithms. You can take the example of this one itself. You can say that it is a toy problem. Not only this, other problems we will, in the coming sessions, I will discuss other problems. Those are all comes under the toy problem. And coming to the real world problems require solutions. Unlike a toy problem, it does not depend on the descriptions, but we should have a general formulation of the problem. So these are the two types of problems. And coming to one more toy problem, everyone are familiar with this, I think. 8 puzzle problem. So this is the 8 puzzle problem. This is the given start state and this is the goal state. And we have a 3 by 3 matrix with movable tiles numbered from 1 to 8. The tile adjacent to the blank space can slide into that. Means here blank is there. So we can move 5, 2 or 6 or 3 into this particular blank space. And the objective here is to reach to a specified goal state similar to the goal state given here. So here in the above figure, our task is to convert the start state into goal state by sliding digits into the blank space. So in this, let us define what is initial state, goal state, actions, transition model, and the path cast. So the states, it describes the location of each numbered tiles and the blank tile, that is the state. So initial state, we can start from anything. So let us make this as the initial state and this is the goal state. And actions. So what actions you can perform on this 8 puzzle? Yes, we can move up, we can move down, we can move right, and we can move left. So these are the actions. See here. Here actions of the blank space is defined by either left, right, up or down. The transition model. So what is your transition model here is, see here, if I make an action up, so what is the resultant of this particular 8 puzzle problem? It will be 7, 4, 5, 2, 6, 8, 3, 1. So the resultant of this particular action, what it is called as the transition mode. So it presents the resulting state as per the given states and actions. So goal state already we have described. This is the goal state. Okay. And path cast. So here, when we are taking some actions, each time, whatever the action you are performing, you are moving only one time, not 2 or 3 tiles at a time. So the past cost is only one tile we can move for each action. So the path cost for this particular the 8 puzzle problem is 1. So see here the same thing. The states, actions, goal test and path cost is 1 per move. Okay. So finding optimal solution for this n puzzle family is NP hard problem. Okay. Why? Because see, we can't reach the goal if it is n puzzle, not the 8 puzzle. 8 puzzle at some point of time definitely will reach to the goal state. But if it is an n puzzle problem, it is like NP hard. And we can say that the total number of state is 9 polynomial. It is, you can see how much depth we are traveling. And so this is how we are going to describe a 8 puzzle problem with the given states and actions and the goal test and the path cast. And some of the real world problems comes this traveling sales uh, person problem. It is one of the real world problem, and VLSI layout problem. These are all comes under the real world problem. And see, when we see the state space search, earlier we discussed that for any particular problem, we can represent with the help of a state space. So this is the state space search of a 8 puzzle problem using the breadth first search algorithm. So we will see what is this BFS in the coming sessions. This is the how the diagram looks like. You can see this is the start state. Somewhere here we reached the goal, goal state. Okay, in this way we are going to draw a tree, so we can say that it is a state space representation, or we can also say that it is a state space tree. Okay? So many duplicates actually there we are removed. That's why this is looking like this. Okay. So branching factor is 1, 2, or 3. You can see here only 1, here 2, here 3, here 1, 2. So we can make approximately branching factor as 2. And there are some other problems are also there. We will discuss in the coming session about these NPIN problems and other toy problems with the help of one example. Thank you.